long do you think the shed should be?
What?
Miguel!
Oh, hi. Didn't see you there. My name is Mickey L. from Blueprint Company. Here at BC, we like to incorporate math and science into our architectural program. So join me as I take you on a trigonometric journey. I hope you brought your hard hats. You're probably thinking to yourself, trigonometry isn't used in architecture. Well, you thought wrong. It is. All the time. Just ask my dog.
That's right, Miguel. Trigonometry is used all the time in architecture. When finding domes, you can use arctants. When finding triangles or just angles, you can use the 6 trig identities. And when finding arcs, you can use arc length. To find arc length, you use the formula S equals theta times R. S represents arc length, theta represents central angle in radians, and R represents radius.
Thanks, dog. Hey, Bill, can you tell me how high this is? Because I can. Trust me. I know.
Well, you see, using tangent, I'm able to calculate the height using the given distance. If you look to the board, you can determine that the distance is 20 feet. Wow! I hope you guys have your 20/20 glasses on, because this is going to be a bumpy ride. Am I right, Bill?
Gee, Bill, it's a good thing I know trigonometry as an architect. Using trigonometry on the lines of a blueprint that don't fall on the x and y axis allows the contractor to know what's going on in the building process as for the angles and lengths. Also, using the 6 trigonometric identities, I'm able to calculate how much material I'll be using before I purchase it. It also lets me save material by knowing where to cut it. Another use for trigonometry in architecture is ensuring that the corners fall into the proper places in rooms and walls. So as you can see, trigonometry is an essential part of architecture. Trigonometry is used all the time in architecture, and the way this is done is with 6 trigonomic identities. The first of them being sine. Sine is opposite over hypotenuse. Now in a triangle, opposite is the line opposite of theta. Theta is the angle in question, while hypotenuse is the largest line of a triangle and is adjacent to theta. The second is cosine. Cosine is adjacent over hypotenuse. Adjacent is the line adjacent of theta, or next to theta, that isn't the hypotenuse. The third identity is tangent, which is opposite over adjacent. The next 3 are tricky. They are the reciprocals of the 3 I just told you. The first is cosecant, which is the reciprocal of sine. The second is secant, which is the reciprocal of cosine. And the last is cotangent, which is the reciprocal. You're probably wondering, how does this apply to architecture? In architecture, triangles are constantly being used for rooftops or buildings. Using these 6 trig identities, you're able to calculate heights or angles for these triangles. For example, let's say you have the given height for a triangle, but you don't know the angle for this height. You can use one of these trig identities to find that angle. Or vice versa, you know the angle but not the height. Using these trig identities, you're able to find the height. How is this useful? Let me tell you. Using trigonometry, you're able to build symmetrical, triangular, and pyramidal structures that last for centuries. The Greeks and Romans demonstrated this in the Parthenon and the Colosseum. Talk about math.
Hey Jennifer, can you help me with number 15?
Oh, okay. So the cotangent of theta equals...
Oh, wait. Speaking of angles, my friend Sam came over, and she said her and her dad are building like this gardening shed. But, here, wait. Let me tell you what she told me. So the building is, or her house is 50 feet away from where their shed is going to be built. But the problem is, she doesn't know what the height. But the only information she got was that the angle was 45 degrees of elevation and that the shed was going to be 50 feet away from her house. I didn't know how to solve it, but I told her you were coming over to help me with math. I don't know if maybe you can explain it.
There's actually two ways I think you can solve it. Okay, so there's a special triangle. And if this is 90 and this was 45 degrees, that means this one has to equal 45 degrees because a triangle has to have 180 degrees altogether. And the theorem says that this is 1, and this would be the square root of 2. And if this is equal to that, that means x equals 50 feet. Another way that you can use it is by sine, cosine, or tangent. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tan is opposite over adjacent. So since we need to find x, and we have 50, and we have 45 degrees as our theta, what you do is opposite over adjacent. So then we would pick tan. When we put this in our calculator, you would use tan of 45 degrees equals x over 50. When you do that, you multiply by 50 to the other side. So when you put that in your calculator, you put tan of 45 times 50, and it equals 50 feet, and that's how you would do it.
Okay. But what if the angle was 30 degrees?
If the angle was 30 degrees, okay, so say this is 30 degrees. Actually, we'll make this 60 degrees. Wait. Okay, so we'll just use 60 right here, 30 degrees here, and 90 degrees here, because there's a theorem that if 60 degrees and 30 degrees and 90 degrees are all in a triangle, then it would be the square root of 3 right here, 2 right here, and 1 right there. So then you would just use the same thing. And if you want to find the height and you're given this, then you would have to multiply this by the square root of 3. And that's how you would find it. Does that make sense?
Yeah.
Okay, but make sure when you put in your calculator that it's in degree mode because we're using 45 degrees here. So since we know now that it's 50 feet, do you want to call Sam?
Yeah. Oh my god. Oh, my head.
I had a crazy dream.
Oh, I know, me too.
We were all architects.
Yeah.
Oh wait. We are.